Okay, question number 1A. There's 2 irons. SO3 is in parentheses. So that 3 is a multiplier through both the sulfur and oxygen. So that would make it 3 sulfurs and 9 oxygens. And then you would go ahead and multiply those by those weights. You add them all together, you get the weight, formula mass for iron 3 sulfite, and that's, since it's formula mass, it's AMU. As you see, the next one is written as a name, ammonium carbonate. So you need to use your polyatomic ion sheet. When you look up ammonium, it's NH4, it's +1. When you look up carbonate, it's CO3 -2. So you have to have 2 ammoniums to go with the carbonate. Then the 2 multiplies through the NH4, there's 2 nitrogens. 2 times 4 is 8 hydrogens, 1 carbon and 3 oxygens. Multiply those out and add them up and you get the formula weight. Formula weight is 96.11 AMU. Alright, question number 2 is listed out as aluminum chlorate. So you look up chlorate, it's ClO3, it's a -1 charge, aluminum is a +3 charge. So then the formula should be Al with 3 chlorates to balance out the charges. Once you do that, you go ahead and add up all your atoms, 1 aluminum, 3 chlorine since it multiplies through the 3, and 9 oxygen since it multiplies the 3 oxygens. Add everything up, it's 277.33. The question's asking the percent chlorine. So the overall mass of chlorine is 106.35. You would take the 106.35 divided by the total times 100. And then once you do that, you get the percent of chlorine, and it's 38.35%. All right, when you look at question 3A, it's asking for an empirical formula. So the steps are change percents to grams, which I've done. Change those grams to moles of atoms of aluminum and oxygen, which I've done. It's 1.96 moles of aluminum and 2.94 moles of oxygen. Once I've done that, I need to get them as whole numbers. So I take and divide both values by the lowest number of moles, which is 1.96. I end up with 1 mole of aluminum and 1.5 moles of oxygen. I realize 1.5 is not close enough, so I have to find a common number, whole number, I can multiply both by to get my whole numbers derived. So I'm going to multiply the 1.5 by 2. That's going to give me 3. Then I'm going to take the 1 times 2 also, because I've got it to do to both, and it gives me 2. So I end up with 2 aluminums and 3 oxygens, so the formula is Al2O3. That's aluminum oxide's formula. Okay, with the next one, on 3B, empirical formula, same as the first one before this. Change percents to grams, change grams to moles. I end up with 2 numbers, 1.3 moles of iron and 1.73 moles of oxygen. I want to get these in whole numbers. So again, I'll take the smallest number, 1.30, divide it into itself as well as the other one. On this one, I get 1 iron and I get 1 1/3, or 1.33 moles of oxygen. So I realize that 0.33 needs to be multiplied by 3, so that it'll come out to be a whole number. So 1 times 3 for iron and 1 times 3 for oxygen will give me 2 numbers. 3 iron I'll need for every 4 oxygens. So the formula on that one would be Fe3O4. Fe3O4 would be my answer. All right, we have 4A. 4A should be pretty easy. They give you an empirical formula, and they give you a molecular mass. So we can realize that if we add up the carbon, there's 1, we have 2 hydrogens, and we have 1 oxygen. We're going to have an empirical formula, mass, of 30.03. Alright? So we realize that's not the same as the molecular mass. So what we're going to have to do is take the 240 and divide it by the 30.03. We should get a whole number out when we make that division. And if you don't, you might just check your work again on your empirical formula and see how that works out. I'm going to come up with 8. 8 is my whole number. So I got to multiply all those subscripts by 8. So original subscript for carbon's 1, so it'd be C8. Subscript for hydrogen's 2, so that's going to be 16. And then oxygen is going to be 1, so that's going to be 8. So my formula is C8H16O8 for 4A. Okay, this is partial setup, and I'm going to finish the setup here for this next one. It's asking you to determine a molecular formula like you did for A, but it gives you percentages, and so with those percentages you have to go through and find the mole ratio involved with that. Okay, so that's what I've done. I've changed percents to grams. I want to change grams to moles. At this point in time, I do have students that will just go ahead and round right now, and that's not right. They're way too far away. They have to be within hundredths of a mole in which to make them a whole number. So if you see, 1.85 is my lowest number of moles, so I'm going to divide it into each one. And that's what you do on all of these. Most of the time almost all the time they're going to be too far away, and you're going to have to manipulate them to get whole numbers. So this first one is 3.04. So that's probably going to be 3. The next one is 3.96. So that's probably going to be 4. And of course the last one is 1. So my relationship, the formula should be, this is the empirical formula, is going to be C3H4O. Okay, as you notice, there's some extra information given that you're going to have to use. And that extra information says 108.16 is the molar mass. So then I need to find the empirical mass. I've got 3 carbons, 4 oxygens, and 4 hydrogens, 1 oxygen. So I'm just going to go ahead and do that. I'm going to write it out since I'm just multiplying them out, and then adding them all up. So the first one is 3 times 12.01, which will give me 36.03. Next one is 1.01 times 4, which will give me 4.04. And then the last one is just 16. I get an answer that's 56.07. Just like the last one, we're going to take the molar mass divided by the empirical mass, and I get an answer out that's 2. So everything has to be multiplied by 2 So when we're done, it should be C6H8O2. Okay, so that's the most difficult problem that you'll have to do related to the quiz tomorrow or on Friday. Okay, number 5. This is like the lab we did. And with that lab, you have 3.22 grams of hydrate. You have 1.42 grams of the residue, what remains after the hydrate or the water is driven off. So what I want to do is I want to subtract out the weight of the residue from the hydrate, and that gives me the water, 1.80 grams of water. So then I need to find moles of Na2SO4, which is 1.42 grams, and I need to find the moles of water, and then I'll compare them. Okay, so number 5, we went ahead and changed grams to moles for both Na2SO4 and for water, and we came out with 0.1s for each. And so that'd be a 1-to-1 ratio.
Not chemistry, so easy. 1-to-1.
Okay, going back through this, it is set up wrong. I noticed that. So the 1.42 divided by 142 would not give you 0.1. It would give you 0.01. So that's a mistake that can be made. Hopefully you won't make it. I did. 0.01 moles of the Na2SO4. So when you compare the moles of water, which is 0.1 moles, to the lower number, 0.01 moles of Na2SO4, you get an answer, it's 10. So then, where I have Na2SO4 dot 1H2O, it should be 10. Okay, dot 10H2O. That's what it should be. So when you do that, you can check it out. Okay, good. Okay, finish up 7A and B. 7A, you got to change grams to moles, and that's what I'm doing. I'm using my molar mass to change it to moles, which is 0.305. And then for B, I'm changing moles to grams.
On the review?
Yeah, this is for the discussion I'm going to send out for everybody. So you guys don't have to comment on this. I'm just going to go through it real quick. And then you can access it later. So 0.44 moles of NO2. You're going to change that into grams. Those would be your answers for A and B on for 7A and B. No, this is 7A and B. Okay? Folks, this is for a discussion I'm going to send out to every group. I've already done the first 5. All right? So don't ask questions on this. You'll see it. Okay? You'll hear this again if you do access it. Okay? Okay, for C and D, the answer is as follows. Change moles to grams. For the lead acetate, it's 0.4 grams you come up with. And then for D, now in D, you're given a molar mass, but you're not going to use it. Okay, so I'm going to give molar masses to all problems. That include problems like 7A through E. So that would be your answers for D, changing moles to atoms. You multiply by Avogadro's number, 6.02 to the 23rd. And then E, the answers would be as follows. You do the opposite, change molecules to moles. And that would be your answer for E. Okay, so that would be all the answers for the review. And if you got further questions, you can come in.